topic of my micro-teach lecture is cost behavior. When I say cost, what I'm talking about are manufacturing costs, okay, production costs. So for example, if we're in the business of assembling bicycles, then I'm talking about the cost of the raw materials like the frame, the seats, the handlebars, the brakes, the pedals. I'm talking about the assembly line labor to put the bicycle together. I'm talking about the cost of the factory itself, the tools, etc. If we're in the business of baking cookies, then I'm talking about the cost of the raw ingredients like the sugar, the chocolate chips, the flour. I'm talking about the wages of the baker. I'm talking about the cost of the equipment like the mixer, the oven, that sort of thing. So I'm talking about production cost. Now what I mean by behavior is I'm talking about the reaction of cost to changes in production. So in other words, I'm talking about what happens when I go from producing 1,000 batches of cookies to 2,000 batches of cookies. What happens to my total cost? What happens if I cut back on bicycle assembly? What if I go from 6,000 bicycles a year to 5,500 bicycles a year? Do my costs decrease? And if so, by how much? Okay? So that's my topic, cost behavior. The reason it's important is it's important for budgeting and for profit planning. Okay? Because management operates in a very uncertain environment. And so to properly plan, management needs to know what costs are going to look like at different levels of output so that it can estimate what income is going to be in future periods. Okay? Now, there are many ways to categorize cost. I'm categorizing based on behavior, and there are generally two cost behavior categories. There are fixed costs. Let's see how I want to do this. There are fixed costs, and there are variable costs. Okay, what's the definition of a variable cost? A variable cost is a cost that varies directly and proportionately with the level of output. So if we put units of output on the x-axis and total variable cost on the y-axis, the cost curve would look like this. Total variable cost varies directly and proportionately with units of production. In total. But on a per unit basis, variable costs remain constant. So this is how we define a variable cost. Variable cost in total varies directly and proportionally with the level of output, but on a per unit basis it remains constant. What's an example of this? Well, one example would be the wages that we pay to our assembly line workers, right? If it takes 1 hour to assemble one bicycle, and we pay our assembly line guy $20 an hour, then to assemble one bicycle, it costs us 20 bucks, right? To assemble two bicycles is what, 40. To assemble three, it's 60, and so on. So the cost is varying directly and proportionally with production, but our wage rate is $20 an hour. It's constant, right? So that's an example of a variable cost. An example, or the definition of a fixed cost, is that it remains constant in total as output changes. Okay? TFC, total fixed cost. And on a per unit basis, it does something kind of funky. It has a curvilinear relationship with units of output. Now, so if management, these are two categories of costs, and if management wants to predict total cost, what it can do then is just simply add up the fixed cost and the variable cost. And because variable costs on a per unit basis are constant, we can also express variable cost as variable cost per unit times the number of units of output. And the reason this is important is now we can, if we have a prior history of what our costs were in the past and what our production levels were, we can use, say, regression analysis to estimate total fixed cost and our variable cost per unit. We can run a regression and estimate the total cost curve, and this intercept here would represent our total fixed cost, and the remainder would represent our total variable cost. So that's why it's important when we're looking at cost behavior to separate these into variable and fixed components so that we can estimate this regression to help us with profit planning in the future. Because now, once we get estimates of what our total fixed costs are and what our total variable cost per unit is, then for any given level of output, we can estimate what our total costs are. And that's why cost behavior is important. Yes?
So, in general, in real scenario, when you increase the number of production, number of units produced, your variable costs also decrease per unit. For example, if you produce 500 bicycles and each bicycle costs you $80, if you produce 1,000, it will probably cost you $70.
That's right. Yeah. We're making a number of assumptions here. Okay. We're making a number, and that's one of them, is that we're operating within what's called the relevant range. You may have heard that term. In real life, there is no cost that is purely variable or purely fixed. But what we're assuming is that we're operating within some reasonable range here. Let's say normal operation is 6,000 bicycles a year. So our relevant range might be between 4,000 and 8,000. And what that means is, hey, if we're operating somewhere next year or in the future between 4,000 and 8,000 bicycles a year, then these estimates will work in helping us to predict what total cost. Now, once we go outside of that range, then all bets are off, and these estimates will no longer be valid. So yeah, you're right. There are a number of assumptions that underlie this model, and that's one of them, is that we're operating in the relevant range. Any other questions?
Thank you.